Assalamualaikum warahmatullahi wabarakatuh and hi. My name is Muhammad Azim Hamidi and I'm from Group 5 in Engineering Fluids Mechanic Lab. In this lab, which is series and parallel pump, I'm going to present about the introduction. So this is the list name of my group members, which is Group 5. Firstly, we start our introduction with the background of pump. In 2000 BC, which is before century, we have the first pump, which is the shaduf, created by the Egyptian to take up water from deep wells. So figure 1.1 shows the example of the shaduf. Second, gear pump. Gear pump was invented in 3rd and 1st centuries. It is invented by the Archimedes, used to take up water for irrigation. Is shown in figure 1.2. For the third one, force pump, it was invented by Sisyphus of Alexandria in Egypt. Uh, it is invented to draw the water via valve using a cylindrical part with a top mounted plunger. After that, we move to the problem statement. The problem statement for this experiment, which is the series and parallel pump, the operating characteristic of the different pumps need to be considered to produce a single combined performance curve using those two arrangements. Then the performance curve for single pump configuration, series pump and parallel pump need to be demonstrated to get the results. Furthermore, the objective of this experiment is to simulate the single pump configuration, series and parallel pumps. Then we need to analyze the pump performance curve by using different methods such as single pump configuration, series pump and parallel pump. After that, the scope of project for this experiment is to focus on demonstrating the pump performance curve for different configuration, as I just mentioned just now, which are single pump, series pump and parallel pump. After we simulate those configuration, the result need to be analyzed based on the pump performance curve. So this is the whole scope of our project.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Umar Syafiq bin Mausuf and my metric number is MA19311. And today I will present about theory for Engineering Fluid Lab 4. So theory for series and parallel pump. First one is the centrifugal pump convert the input power to kinetic energy in the fluid by driving the fluid through a rotating system. Next, fluid is entered into the pump through a high-speed rotating impeller's eye, and then the fluid is driven radically by the pump. Then the impeller eyes produce vacuum that push more fluid constantly into the pipe, and this is the formula for the pump. Calculate pump, and then there are two type of pump, which is a parallel and a series, as you see below. That's all for me. Thank you.
A very good day to my lecturers. My name is Vignesh with metric ID MA20019. I will be presenting to you our report's method and procedures. Firstly is our equipments. All equipments were numbered to give viewers a better understanding of the system. At number 4, 5, 6, 7 and 8 we have the valves. We have two centrifugal pumps at 9 and 10. At 11 we have our switch box to turn on the pumps. Number 13 is the intake side of the pump 1. Number 14 is the delivery side of pump 1. Number 15 is intake side of pump 2. 16 is delivery side of pump 2, and also the outflow at 17. Once the equipments are set up, this is how it should look like. The single pump operation began by connecting the stopcocks as shown in figure 4. Initially the valves were closed. by pushing the handle parallel to the pipe. To open the valve, the handle was pushed perpendicular to the pipe. Pump 1 was switched on after the main switch on the switch box. Pump 2 must remain switched off for this experiment. The volumetric flow V was set with the drain cock. Continuous inflow of water into the reservoir was ensured. P suction was measured on the intake side of the pump and P delivery was measured on the delivery side of the pump. Finally, the experiment was repeated by following the previous procedures with different volumetric flows V. As for the series pump operation, the experiment began by connecting the stopcocks as shown in figure 5. Both pumps were switched on after the main switch on the switch box. The volumetric flow V was set with the drain cock. Continuous inflow of water into the reservoir was ensured. P suction 1 was measured on the intake side of pump at 13. P delivery 1 was measured on the delivery side of pump 14. P suction 2 was measured on the intake side of pump 2 at 15. And P delivery 2 was measured on the delivery side of the pump 2 at 16. Finally, the experiment was repeated by following the previous procedures with different volumetric flows V. Finally, for the parallel pump operation, the stopcocks were connected according to figure 6. The steps are similar as the series pump operation, except for this operation, P outflow was measured at the outflow, which is at 17. That is it from me. Thank you.
My name is Nur Atifah binti Masri, Metro ID MA 19308. So today I will present about the result for Lab 4 series or parallel pump. Okay, this is the data for the single pump data. The given data is a volume flow rate, suction pressure, delivery pressure. What we have to do is find the net pressure, which is the P single. We can find this by delivery pressure minus suction pressure, and then we got the value for the net pressure. And then for the net head here, we use the formula H equal to P over rho G. Rho is defined by the density which is 1000, and the G is the gravity acceleration, which is 9.81. And then for the water horsepower here, we use the formula horsepower equal to rho GQH. Rho, which is the density, G gravity acceleration, Q is the volume flow rate, and then H is the net head of the pump. And then proceed. Here we have the pump data. So same with the single pump data. The given data is volume flow rate, P suction 1, P delivery 1, P suction 2, and P delivery 2. And then for the net head is it's the same for the single data, which is H equal to P over rho G. But here for the series pump data, we have to add the pressure, which is the delivery pressure 1 and delivery pressure 2 over rho G. The horsepower is same. The formula used for all the pump data is the same. And then we have lastly the parallel pump data, also same like series pump data. The given is volume flow rate, P suction 1, P delivery 1, P delivery 2, and P suction 2. The net head here is quite differ because the pressure, we take the value pressure here is only the P delivery 2, because it's corresponding to the pump with the lowest delivery pressure. And then horsepower using the same equation. And then we have the graph of the series pump. This is the head, this is the volume flow rate for single pump. The trend increasing toward the volume flow rate. And here we have the graph series and parallel pump, which is head versus volume flow rate. This is for series pump, and then this is for parallel pump. It's the same, have the trend increasing trend line. And that's all. Thank you. Now let's proceed to the discussion.
Assalamualaikum. My name is Muhammad Ahmad Jufri bin Muhammad Safri. ID numbers is MA203. Now I would like to present about discussion parts of configuration. Okay, this is the first question. Question A is compare the experiment performed curve to its theoretical curve and describe the discrepance factor. Based on a comparison of the actual and predicted performed curve, we may conclude that the parallel pump has the highest flow rate and the series pump has the highest heat. When comparing the experiment and theoretical curve, the experiment curve shows a significant difference. Data for the experiment outcome is unreliable due to pipe loss and flow rate fluctuation during the operation. Next, question number 2 is from the result obtained state the use of series and parallel pumps. Series pump is the head of the system can be increased twice with a series pump configuration. It works well with pumps that have a high flow rate but a low heat. A pump design known as series pump is utilized to overcome a high static discharge rate. Actually, parallel pump for the same head, parallel pump can quadruply the flow rate. It works with right head pumps that have a modest flow rate. Parallel pump with variable speed can save energy while enhancing efficiency and control. For the last question is explain why the system with series pump configuration will generate higher pressure than the parallel pump configuration. The pumps are connected in series to compensate for bigger system at loss than a single pump can tolerate, and they can boost system heat twice at the same flow rate. In contrast, a parallel pump design can treble the flow rate for the same heat. The heat provided by a series pump is double that of a parallel pump, result in higher pressure. The pressure rises as the net heat rises. Okay, this was from me. Thank you.
Okay, back to me. So lastly, I'm going to discuss or present about the conclusion for our lab 4, which is series and parallel pump. So the conclusion for this experiment, each of the pump configuration produce different results based on the result that we get from the experiment. Then, for series pump, the pumps can deliver totally different level of heat if the operating capacity keeps the same. So this we get from the theory of the series pump. After that, the theory for the parallel pump, the flow rate is shared with other pumps since each pump operates at the same heat. The theory knowledge of series and parallel pump is same with the results that we get from this experiment. Then, according to the results, the series pump configuration has the highest net heat in meter compared to other pump configuration, which is 91.01 meter. Other than the net heat, the parallel pump configuration has the highest volume flow rate compared to other configuration, which is 0.004697 meter cube per second. Lastly, to complete our experiment, the parallel pump has the highest flow rate, while the series pump has the highest net heat. So that's all from me and our group. Thank you.